Hello everyone, I am Vipin Garg, PGT Mathematics, JNV Moregaon, and again we are here for our next chapter, that is three-dimensional geometry. In class 12th board examination, out of 80 marks, there is a unit of these two chapters, vector algebra and three-dimensional geometry, which consists around 14 marks, which is around 17% of the total marks. So this is very important for scoring in the board examination. So in this chapter, three-dimensional geometry, we will talk about the basics of the chapter, which concept, which formulas are to be used, and some questions on previous year based questions. Okay, the questions are taken from the last year board examination, so that you can have a rough idea that how questions are going to be presented in the board examination. Fine. So first of all, I will talk about the key objectives of the chapter. So first of all, we need to know, that is direction cosines and direction ratios. Okay, so what are the direction cosines and what are the direction ratios? Okay, I know you have studied all these things. I am just recapitulating the things for you, so that all the formulas, all the identities, methods can be revised for you. Okay, in a very nutshell, we will do this. Let us suppose this is a three-dimensional graph. We are having three coordinate axes. This is the origin, and this is the x-axis, y-axis, as well as z-axis. If any point is there, P, okay, and if we join this point with origin, just try to look this in the three dimension. Okay, this point is not on the board, this is in between you and the board. Okay, so this is in air here. Okay, suppose my finger is here, so P may be here also. So when we join P with O, then this line OP is making three angles at a time, with positive x-axis, with positive y-axis, and with positive z-axis. So let the angle made by the line with positive x-axis be alpha, with y-axis be beta, and with z-axis be gamma. So if these three angles are there at a time, so the value of these three angles, cos alpha, cos beta, cos gamma, this will be known as the direction cosines of the given line. So every line in the space will make three angles at a time with the coordinate axis. So always a line will be having these three directional cosines. Okay, this is shown by L, M, N also. L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. And there is a very interesting point about this, that the values of alpha, beta, and gamma is always like in such a way that L square plus M square plus N square is always equal to 1. So L, M, and N are known as the direction cosines of the line. Fine. Now, what are the direction ratios? Okay. For every LMN, there will be three values of A, B, C. If we divide A, B, C by we will divide LMN by A, B, C respectively, then the value will be equal. If such situation is there, then if A, L, M, and N are the direction cosines of any line, then A, B, C will be the same line's direction ratios. And if L square plus N square plus N square is equal to 1, where A square plus B square plus C square is always equal to the magnitude square of the line. Suppose the magnitude of this line OP is equal to R, then A square plus B square plus C square will be equal to R square only. Fine. So first point is clear, that is the direction cosines and direction ratios. So coming to the next point, and that is the direction cosines of a line when joining two points. Suppose this was the situation, we have to find the direction cosines of the line when the angles made by the line to the coordinate axis were given. But suppose if angles are not given, then how to find out the direction cosines? Suppose a line is there and we know that these are the 2 points x1 y1 z1 and x2 y2 z2. These 2 points are given on any line AB or PQ or OA, OB, whatever is this. If 2 points are given, then how to find out the direction cosines of the line? Then L is equal to x2 minus x1. Direction ratios we will find A, B, C. A will be equal to x2 minus x1, B will be equal to y2 minus y1, and C will be equal to z2 minus z1. So the direction ratios will be x2 minus x1, comma y2 minus y1, comma z2 minus z1. These are the direction ratios. But how we will find the direction cosines? Then L can be find out by A by a square plus b square plus c square. M can be found out by b by root a square plus b square plus c square, as well as n can be find out as c by a square plus b square plus c square. So this is the method to find the direction cosines and direction ratios of a line when 2 points are given. Whenever 2 points are given, firstly we will find out the direction ratios, and then substituting the values in this L, M and N, we can find the direction cosines of the line also. Again, I am just reminding you, I am not giving you the basic concept knowledge, because I know that at this time you must have the knowledge of the all chapters. I am just giving you the recapitulation of the concept so that you can prepare for the CBSE board examination in a nice way. Fine. So coming to the next point, that is the equation of a straight line. So our next topic will be equation of a straight line. Equation of a straight line. So last topic was the 2 points. How to find out the direction cosines and direction ratio when 2 points on a line are given. So now the equation of a straight line. Every line has an equation. When you were in the class 10, if you remember, we used to solve the pair of linear equations in 2 variables. That was the first introduction of any line by an equation. What was the general equation? That was ax plus by plus c is equal to 0. Similarly, in 3-dimensional also, every line can be represented as an equation. So first of all, before representing any equation of a line, I just want to remember that equation is the combination of constants and variable, but this is the vector. So vector and 3D. So how to introduce the equation of a line? So what will be the variable vector? So the variable vector is given by r vector, and as you know, this is the 3-dimensional. So the general vector, the variable vector will be xi plus yj plus zk. This is the variable vector. So whenever we are writing the equation for a line, we will use r vector as the variable vector. So the equation of any line is vector a plus lambda vector b. So what is r? So now what is r, what is a, what is lambda, and what is b? So r is the variable vector, and vector a and vector b are also 2 vectors. Lambda is just any scalar value, any constant value, but vector a and vector b. Vector a can be defined as any point on the line of this given line AB. This is the line AB. Then if A vector is the position vector of any point on the line, that can be written as the vector A. Similarly, vector B is the direction vector of line AB, because the equation of any line is always depends on the 2 things. Any point on the line, the line is passing through which point and what is the direction of the line. So this is the general equation of vector of a line. Vector r is equal to vector a plus lambda vector b. So this is called the vector form of equation of the line. It can be written as in the form of Cartesian form also. Okay, so Cartesian form is x by x1 is equal to by a is equal to y minus y1 by b is equal to z minus z1 by c. So what is the x1, y1 and z1? These are the coordinates of the point vector a. Okay, position vector, if it is written as the vector, then vector a will be equal to x1i plus y1j plus z1k. Similarly, vector b is the direction vector, so these are the direction ratios a, b, c. So this vector b is equal to ai plus bj plus ck. Okay, and vector a is the position vector of the point, any point on the line. Fine. So this is the Cartesian equation of the line and this is the vector equation of the line. So now the next topic is 2-point form. The next topic is 2-point form. This is the form where we find out, we can find out the equation of a line which is passing through two given points. Okay. If a line and 2 points are given, x1, y1, z1 and x2, y2, z2, then what will be the equation of the line? Suppose these are the coordinates of point A and these are the coordinates of point B. No direction vector is given, then how to find out the equation of the line? So in the last point I have told you about the how to find direction ratios of a line. Whenever 2 points are given, then direction ratios of line AB will be x2 minus x1, y2 minus y1 and z2 minus z1. This is the value of A, this is the value of B and this is the value of C. So the equation will be revised to x minus x1 by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 and z minus z1 by z2 minus z1. So this is the 2-point form of equation of a line. So this is about, and now if we will talking about the vector equation of this point, so this point can be taken vector A and this point is taken as vector B, then what will be the direction vector? Vector B minus A. So the required equation will be vector A plus lambda B minus A. So don't get confused between the two forms. At the first type of equation, A vector is the point vector, B vector is the direction vector, but now A and B both are the point vector. So to find out the direction vector, we have to subtract firstly A from B, or B, A minus B or B minus A. If you are talking about A minus B, then here you can use B point also. Okay, so the next point is skew lines. One point you just have to keep in your mind, this is not a coplanar. We are not talking about a single plane, we are talking about the 3D. We are in the space. So in the space there are many lines. In a, suppose this is the green board. Now okay, we can see the green board. On this green board, if you draw any two lines, these lines will either intersecting or parallel. If these are not parallel, these will be intersecting line. But in a space, when we are talking about in the three-dimensional geometry, then two lines need not to be parallel as well as or perpendicular. They can be skew lines. Skew lines are the lines. Suppose one line is passing through this place and another line is passing through this place. So now you can see about these two lines, these two lines are neither parallel nor intersecting. Okay, this can be like this. So these type of lines are known as the skew lines. Okay, so the next point is the angle between two lines. Whenever two lines are intersecting with each other, then how to find out the angle between two lines? So here we can revise one topic from the chapter of vector algebra. Whenever we have to find out the angle between two vectors, what was the formula? Cos theta is equal to A dot B by A magnitude and B magnitude. So now if two lines are there, equation is point A plus lambda B1 and this is A2 plus mu B2. Then how to find out the angle between? Firstly tell me if two lines are making an angle with each other, the angle is depending on the point passing through the line or the direction of the lines. Fine. So what is the reason? Yes, the direction of the line defines ki how the line will go and what will be the angle between. So mainly the angle between the two line actually is the angle between the direction vectors of the line. So the angle will be cos theta is equal to b1 dot b2 divided by b1 dot b2 magnitude. Okay, so A will be the direction vector of the first line and B will be the direction vector of the second line, that is B1 and B2. Fine. So this is the how to find angle between two given lines. I am just erasing all the points because in the video you can revise the things by going back. If you want to revise any point, you can take 10 seconds or 20 seconds back and you just listen to it whenever you want. Okay, so that revision can, because we have to finalize this chapter as soon as possible. So next is the shortest distance between two lines. Shortest distance between two lines. Okay, shortest distance between two lines. Fine. So I just talked about two skew lines. Okay, the two skew lines are there which are non-intersecting, non-parallel. Okay, so there will be the different distances if from the we are finding the distance from this point to this point and this point to this point. So there may be many distances, but at suppose this point, this is the distance which is shortest between two lines. So this distance we have to find out, and this is one of the important questions because in every 5 years 2 to 3 times this question can be found in the final examination of the CBSE board examination. So if a line, first line is having the equation vector a plus lambda b1 vector and second line is having the equation vector a2 plus mu b2 vector, then what will be the shortest distance between two lines? That is a2 minus a1 dot b1 cross b2 divided by magnitude of b1 cross b2 vector. So you have to find out firstly the difference between the point vectors, position vectors, and then the direction vectors cross product, and the magnitude of the cross product if divided here, then if you will find the shortest distance. But we know that distance cannot be negative, but this value can be both positive and negative, so we will take this as the modulus there. Absolute value function will be taken here because distance cannot be negative. So this is the point also. Now two more concepts can be also defined here, ki how to find the distance of a point from a line and the image of the point in the same line. Similarly, the distance can be perpendicular or the distance can be measured parallel along with another third line. So there are many concepts related to this. So now we will go for some practice questions. So now the first question is, if a line makes an angle 30 degree with positive x-axis and 120 degree with positive direction of y-axis, then find the angle which it makes with positive direction of z-axis. Okay, so practice, in the practice questions, the first question is, a line is there, suppose OP line is there which is making an angle of 30 degree x-axis y z. So you will be finding ki how this can be 30. So this is not the 2D plane, this is the 3D plane. The line is coming like this only. Okay, this line P, which is we can find this line on the board. This is not on the board, actually this is between you and the board. This line is suppose like this, so this angle can be 30 degree. Okay, so this angle also can be 30 degree. So this chalk I just showed as a line. So 30 degree and 120 degree with the y-axis. Similarly, z-axis angle is not given, that is gamma. So I told you in the very first point ki alpha, beta, gamma are the angles made by a line with the coordinate axis. So alpha is given equal to 30 degree, beta is given equal to 120 degree. We have to find out gamma. What is the value of gamma? So you remember LMN. LMN are the direction cosines. L is equal to cos alpha. So cos 30, M is equal to cos beta, which is cos 120 degree, and N is equal to cos gamma. So L square plus M square plus N square is always equal to 1. So cos square alpha plus cos square beta, cos square 30 plus cos square 120 plus cos square gamma is equal to 1. What is the value of cos 30? Cos 30 is root 3 by 2. So root 3 by 2 ka whole square plus cos 120. So now what is the value of cos of 120 degree? We know that ki 120 degree lies in the second quadrant, and second quadrant cos theta is negative. So this value will be negative, but cos of 120 can be given as 180 minus 60 degree. In the trigonometric basis we have learned about this all quadrant system. So here cos 180 minus cos 60. Cos 60 is 1 by 2. So the value for cos 120 will be minus 1 by 2. So minus 1 by 2 whole square plus cos square gamma is equal to 1. Okay, this is the rough. So 3 by 4 plus 1 by 4 plus cos square gamma is equal to 1. 3 by 4 plus 1 by 4, 4 by 4. 4 by 4 is equal to 1. 1 plus cos square gamma is equal to 1. 1 plus cos square gamma is equal to 1 means cos square gamma is equal to 0. So cos gamma is equal to 0. Whenever an angle is giving the 0 value on cos, it means angle is 90 degree. So angle is 90 degree. So this is the angle made by the line with the z axis. So the next question you can see, that is the direction cosines of a line are root 3k, comma root 3k and root 3k, then the value of k is. So this is the situation where the coordinate axes are having same angle with the line. The line is making the same angle, equal angle with the all three coordinate axes. So this situation is known as the equally inclined line to the coordinate axis. So equally inclined means L is equal to M is equal to N. So how we can solve this question? Equally inclined is this. So L is equal to given root 3k, M is equal to given root 3k and N is equal to given root 3k. So L square plus M square plus N square is equal to 1. So root 3k whole square plus root 3k whole square plus root 3k whole square is equal to 1. On squaring on both sides, on squaring we can get the square root 3 is equal to 3, and this is k square. So 3k square plus 3k square plus 3k square is equal to 1, which is equal to 9k square is equal to 1. So on simplification, k square is equal to 1 by 9 and k will be plus minus 1 by 3. So k can have both the values plus minus 1 by 3. So if it is a multiple choice question and options are there, a is 1 by 3, b is minus 1 by 3, c is 1 by 2, but d is equal to plus minus 1 by 3. So we can see that 1 by 3 is also the value of k, minus 1 by 3 is also the value of k, but these two values are there. So plus minus 1 by 3 will be the right option. These will not be the two right options because answers can be more than one, but these are given single time, and so this is covering all the points. That's why the correct option will be D. So the next question is the coordinates of the foot of perpendicular drawn from the point 0, 1, 2 on the x-axis are given. Suppose a point is given 0, 1, 2 on x-axis. We are drawing the foot of perpendicular. So what will be the foot of perpendicular? Okay, so suppose this is the point 0, 1, 2. Okay, what are the coordinates of this point? A, B, C. Any coordinates of a point P, A, B, C means ki A is the x coordinate. So if we will draw a perpendicular on the x axis, so other, okay, direction will be the same. So the coordinate of x will be the same, but on x axis we know that y and z are 0. So any coordinate on point x axis is a 0, 0, and on y axis is always 0, b 0, and at z axis it will be 0, 0, c. So whenever you are drawing a perpendicular from any point to the x axis, y axis or z axis coordinate axis, then except that coordinate axis value, all other values will be 0. So on x axis if we are drawing the perpendicular, then x will be the same, but it is already 0, so y will be 0, z will be 0, so the coordinates of the foot of perpendicular will be 0, 0, 0. Fine. And similarly, if you have to find out the distance, if you have to find out the distance of a point from any coordinate axis, okay, so the formula for the distance of point PABC, suppose you want to find out the distance from the x-axis, then leave x, other two values are there, so the distance will be root b square plus c square. This is the distance from x-axis of the point ABC. Similarly, if you want to find out the distance of the point from the y-axis, what will be the value? Yes, what will be the value? If you want to find the distance from the y-axis, so leave the value of y, then other two values square and square root, a square plus c square. Can anybody tell me what will be the distance of the point from the z-axis? What will be the distance? It will be root a square plus b square. So two concepts in this question I have discussed with you: how to find out the distance of a point from the coordinate axis, and second thing, how to find out the foot of perpendicular if perpendicular is drawn to the coordinate axis from any point. So the next question is direction ratios of a vector parallel to the line. Suppose a line equation is given: x minus 1 by 2 is equal to minus y is equal to 2z plus 1 by 6. Whenever two lines are parallel, it means their direction ratios are equal but points are different. If we want to find out the direction ratios of a line which is parallel to the given line, so first of all we have to find out the direction ratios of the given line. So for that we have to convert this equation in the standard form of Cartesian equation or vector equation, which is known as, the Cartesian is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So this is the general equation or Cartesian equation of a line. So first of all we have to change this. So x minus 1 by 2 is there, x minus 1 by 2. But if any number variable minus only y is given there, so what we can do? We can write any number in the form of y minus 0. Similarly, y can be written by 1. I am just taking both the points just along with, so I will write this y by 1 and y is equal to minus 0. So similarly, y minus y1 by b is equal to y minus 0 by 1, but this is also minus, so minus will be taken in the denominator, so the general form will be y minus 0 by minus 1. Did you get this point? Similarly, we have to find out z minus z1 by c, but you can see in the general form of the equation there is no coefficient given with the z, but here in this equation we have 2 with as a coefficient of z. So first of all we will divide numerator and denominator by 2. So dividing the numerator and denominator by the same number, that is 2, we will get z plus 1 by 2 divided by 3. So if we talking about the direction cosines, direction ratios of a line which is parallel to this line, so the direction ratios will be same as the direction ratios of the given line. So what are the direction ratios? If you will compare with the general equation, the value of a, b, c will be the required direction ratio. So value of a is equal to 2 and value of b is equal to minus 1 and value of c is equal to 3. So the direction ratios of the required line are 2, minus 1 and 3. So this is all from this question. Okay, let's move to the next question. So in this series, the next question is the equations of a side of a parallelogram ABCD are as follows. One question is given, one parallelogram is there ABCD. The equation of the line AB is x plus 1 by 2, x plus 1 by 1 is equal to y minus 2 by minus 2 and z minus 1 by 2. Similarly, the equation of BC is given, the equation of CD is given and the equation of DA is given. The equation of BC is x minus 1 by 3 is equal to y plus 2 by minus 5 is equal to z minus 5 by 3. Similarly, the equation of CD is given x minus 4 by 1 is equal to y plus 7 by minus 2 and z minus 8 is equal to 2. Z minus 8 by 2. So the equation of DA is given x minus 2 by 3 is equal to y plus 3 by minus 5 is equal to z minus 4 by 3. So this is the equations of the lines of the sides of a parallelogram ABCD. So parallelogram ABCD is there. So we have to find the equation of BD. AB is given, BC given, CD given and DA given. Now we have to find out the equation of BD. So this is the BD. But whenever we have to find out the equation of any line BD, then we need at least 2 points. So first of all, we have to find out the coordinates of the point B as well as the point D. So now you can see where is the point B. Point B is the common point, the point of intersection between AB and BC. Similarly, the point D is the point of intersection between CD and DA. So to find out the coordinates of point B and D, we need to find the point of intersection. So for that, let us start for the point B. B point is the point of intersection between line AB and BC. So the equation of AB and BC, let us is equal to K, or lambda and mu can be taken. Okay, so let us AB is equal to lambda and BC is equal to mu. So from here, if we will put x plus 1 by 1 is equal to lambda, then x will be equal to lambda minus 1. Similarly, y will be equal to minus 2 lambda plus 2. If we will put z minus 1 by 2 is equal to lambda, then z is equal to 2 lambda plus 1. So these are the values of x, y, z on equation AB. It means xyz, what is the xyz? Xyz is the variable vector of line AB. So xyz be the coordinates of any general point on the line. So the any point on line AB, the coordinates will be lambda minus 1 comma minus 2 lambda plus 2 and 2 lambda plus 1. These are the coordinates of a general point. Let us say the coordinates are of point B. Similarly, if we will take about the BC, then the value of x will be 3 mu plus 1 and y is equal to minus 5 mu minus 2 and z is equal to 3 mu plus 5. So again this point x, y, z is the general point on line BC, so it can be any point. So again I can take the coordinates of B point because that is also lying on the line BC. So the B coordinate of B will be 3 mu plus 1 minus 5 mu minus 2 and 3 mu plus 5. So these are the coordinates of the point B. So now we can see this is the point B and this is also point B. So if both the coordinates of are the same point, because point B lies on AB as well as BC, so it can be equal. So whenever the two coordinates are given and both are for the same point, so x1 will be x1 will be equal to x2 and y1 will be equal to y2 and similarly z1 equal to z2. So equating the values we will get, so I am just okay. So the first coordinate is lambda minus 1, that can be equal to 3 mu plus 1. If we will simplify this the equation, it will be lambda minus 3 mu is equal to 2, equation number 1. Similarly, if y1 is equal to y2, then minus 2 lambda plus 2 is equal to minus 5 mu minus 2, so it will be minus 2 lambda plus 5 mu is equal to minus 4, equation number 2. Similarly, equating z, we can have 2 lambda minus 3 mu, 2 lambda minus 3 mu is equal to 4. These are the three equations. Now you can see there are three equations in two variables, that is lambda and mu. If you remember in the class 10, there was a chapter of pair of linear equations in two variables. There we used to solve the two equations for two variables x and y, and for that we need two equations. But here we are having three lines. So in place of solving all the three, you can choose any two equations and you can select. If I am, suppose for example, I am just solving the equation number 2 and 3, so minus 2 lambda, it will be 2 mu is equal to 0, so mu is equal to 0. Substituting the value of mu in the equation, 2 or 3, we will find out the value minus 2 lambda plus 0 is equal to minus 4. So lambda will equal to 2. Now we have lambda is equal to 2 and mu is equal to 0. So how we will use the equation 1? What we will do, we will use both the values of lambda and mu in the third equation, that is the first equation. If we will use in the first equation, if it is true, it means the two lines are intersecting, the point of intersection is there. But suppose the two values of lambda and mu are not satisfying the third equation, and then that is the case of the two lines which we are finding the common point, they have no common point and they are non-intersecting lines, these are the skew lines. Fine. So substituting the value lambda is equal to 2, 2 minus 3 into 0 is equal to 2, which is true. It means these are the intersecting lines. So now we have to find out the point of intersection. Here you can see we have two different values of x and y and z. So for this we can find out the value of x, y, z substituting the values of either lambda or mu. So I will using the value of mu. So x will be equal to 3 into 0 plus 1, that is 1. Y is equal to 0 minus 2, that is minus 2. And z is equal to 0 plus 5, that is 5. So the coordinates of the common point will be 1, minus 2 and 5 for the common point B. Similarly, you can find out the common point, the coordinates in CD and DA. For that you will find the coordinates of the point D, that will be like some value of x, y, z. Okay, now we have the coordinates of point B and coordinates of D. So how we can find out the equation of BD? Whenever 2 points are given, then use that 2-point form. How to find out the equation of a line which is having 2 points? You use x minus x1 by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 by z2 minus z1. Here x1, y1, z1 are the coordinates of the point B, and x2, y2, z2 are the coordinates of the point D. So using these points we can use we can find out the value, we can find out the coordinate equation of the line BD. So this is also one more example. So I am also sharing the PPT for the questions. How many questions are based from the last previous year questions? So you just go through that. If any doubts are there, you can contact me by mail or by phone number also. So you can have your personal doubts in comment section also. We will try to answer your doubts. So this is all from my side, and once again I am just thanking you for watching the whole video. My name is Vipin Garg. I am PGT Mathematics in JNV Moregaon, Assam. Thank you and goodbye.